name is Kimberly Oakes. I am a fourth-year PhD student in the Electrical Engineering Department at RPI. At RPI, research labs such as the robotics lab I work in can be very interdisciplinary. Located in the low building shown, our lab typically contains electrical, computer, and mechanical engineers and promotes a collaborative working environment. The robotics lab has multiple ongoing projects. Research is performed by both undergrad and graduate students. One area of the lab is dedicated to assistive care. This robot is being programmed to help paraplegics perform daily tasks. Another area is space robotics. There are two dual-arm robots that are utilized in this area. To the left is Motoman, a hydraulically driven industrial robot. It works well for precision tasks, but is unsafe to be near while operating due to its power and lack of built-in safety features. The other is Baxter by Rethink Robotics. Baxter is a newer type of industrial robot designed for collaborative tasks. The joints contain series elastic actuators, which result in joint flexibility. This compliance makes Baxter safer to work alongside. We also utilize an air-bearing table to simulate a zero-G environment. Objects such as the one shown can be easily moved due to air bearings on the object, forming a cushion of air between itself and the granite table. This cancels much of the gravitational and frictional forces, making it a viable option for simulating some space scenarios. My research is funded by NASA's Goddard Space Flight Center in Greenbelt, Maryland. This is one example of the many opportunities available to collaborate with companies, other universities, and research facilities. My work focuses on control of flexible joint manipulators. The motivation for this work is the Restore-L mission. In this mission, a satellite will be refueled by another using a robotic arm. There are several challenges, including, but not limited to, flexible joints caused by harmonic drives, and inertial effects of transporting a large load. My research specifically focuses on generating a robust controller that can accurately track a desired trajectory with or without a large load in the presence of nonlinearities such as friction. Experimental testing of the methodology developed is done using Rethink's Baxter robot. As stated previously, it has series elastic actuators which result in flexible joints. Additionally, it has a low payload capacity. These two characteristics, which are qualitatively similar to the Restore-L, make it a useful platform for experimental testing. Baxter provides some additional difficulties of interest in research. The dynamic model for Baxter is unknown and many of its parameters cannot be readily measured. For this reason, my research also looks into designing controllers for a nonlinear system using experimental frequency response data. To further increase the similarity of the experimental setup to that of satellite servicing, an air-bearing table is used. The object being manipulated is 14 kilograms, whereas Baxter's payload capacity is 2 kilograms. The air bearings allow this object to be transported. However, much care needs to be taken in the trajectory generation and controller design to avoid oscillations which may lead to instability. This is visible in the example where it is shown that additional smoothness for a desired trajectory helps reduce oscillations. Future work will include transporting this object using both arms. RPI offers many classes and extracurricular activities which emphasize self-learning and exploration. Many classes are designed to push you outside the classroom through projects which relate to both your interests and the course material. The professors are dedicated to helping students understand and apply the material. Here is an example of the project I worked on in Robotics 1. This project utilized computer vision and inverse kinematics, both important concepts for real-world robotics. If you have any additional questions about RPI and research, contact me at the email provided. I hope this video allows you to make a more informed decision about attending RPI. Thank you for viewing and good luck in your future endeavors.